Something's wrong with these images. What you're looking at right now was captured not by NASA, not by a deep space probe, but by an amateur astronomer, Paul Craggs, using equipment that shouldn't be able to do this. Yet somehow his telescope locked on to 3I Atlas and revealed a shape that looks deliberate. A long, rigid spine wrapped in a faint electric blue halo, a structure that holds its shape with uncanny discipline as it drifts across a star field. This isn't the messy blur of a melting comet. It isn't fragmentation. It isn't noise. It's structure, clean, consistent, and eerily precise. And now more amateurs are capturing the same impossible details, independently, from different parts of the world. Something is happening with 3I Atlas, something we were never supposed to see. NASA has never shown anything like this. Their official images remain low-resolution smudges, the kind that tell you almost nothing about the object's form. But Craggs, along with a growing number of amateurs around the world, has shown us something else, something sharper, cleaner, and uncomfortably precise. These new images feel like a glimpse through a keyhole, revealing a truth that larger institutions appear unable or unwilling to show. The moment you place Craggs' image beside a typical comet, the unease sets in. Natural comets are messy creatures. They shed uneven plumes of dust, their comas ripple into asymmetry, and their tails twist depending on solar wind and rotation. To anchor that comparison, many astronomers point to recent captures of ordinary fragmenting comets. Ragged, drifting, unstable. They fall apart in unpredictable ways, leaving behind ghostly trails of debris like a ship losing its hull. That's how they're supposed to behave. But 3I Atlas is not doing any of that. If anything, it's doing the opposite. Holding steady, holding shape, holding form. Against that scientific backdrop, the new amateur images pour gasoline on the mystery. One remote observer in Spain locked onto the object using a modest observatory setup. The result? A nucleus as stable and centered as a studio photograph. No star smearing, no coma distortion, no drift. Just a compact body with surprisingly well-defined boundaries, as if the telescope had been tracking something with deliberate control rather than a chunk of interstellar debris tumbling through space. Even more startling is a sequence shared by Dr. Horace Drew, using processed footage originally captured by Ray's Astrophotography. At first glance, it appears to show nothing more than a bright point of light surrounded by a faint haze. But once enhanced, the object pulses. Not flickers, not jitters, pulses. Its brightness swells and contracts in a repeating rhythm, almost like a heartbeat. Drew noted that the behavior could be fitted to a mathematical curve, suggesting periodicity rather than randomness. If that's true, then 3I Atlas isn't just brightening, as comets do when exposed to sunlight. It's exhibiting a cycle. When amateurs around the world begin reproducing the same patterns, from Florida skywatchers to European observers, the pattern becomes harder to dismiss. Night after night, independent captures show structure slowly emerging from the noise, as if the object is revealing itself layer by layer. A slight elongation one night, a sharper core the next, a smooth, symmetric glow a few nights later, and finally, Craggs' image, the most striking yet, the kind that makes seasoned astronomers pause. By this point, the central question becomes unavoidable. Why are amateurs producing clearer images of an interstellar object than NASA? There are many diplomatic answers: differences in exposure time, unrelated mission priorities, the slow pace of public data releases. But none of these explain why low-cost telescopes are showing clean geometry while professional ones show little more than an overexposed blur. These amateurs do not coordinate with one another. They use different equipment, different processing methods, different tracking styles, and yet their results converge toward the same uncanny clarity. Across these captures, another pattern emerges: symmetry. Symmetry is rare in natural comets, very rare. Dust jets curve and twist, outgassing produces chaotic turbulence. The nucleus surfaces are uneven, cracked, battered by eons of collisions. But here, observers report straight edges, repeating angles, a consistent axial structure that doesn't appear to warp or flicker. One enhanced frame even reveals a circular cross-section, as if the object were a smooth sphere rather than an icy shard. Another looks like a long cylindrical core wrapped in a thin envelope of light. That is where the scientific anomaly enters the conversation, one described by Harvard astrophysicist Avi Loeb in his analysis of 3I Atlas. In a recent article, he listed a series of anomalies organized by likelihood, and among them was a particularly troubling one: the object's unexpectedly stable symmetry. Loeb argued that its shape, motion, and brightness did not match any known natural template for interstellar debris. Symmetry, in his words, is something nature rarely maintains at interstellar speeds, especially for objects exposed to the harsh reality of space erosion and rotational stress. If these new amateur images truly reflect the object's form, then Loeb's earlier anomaly suddenly gains visual support. A mathematical oddity becomes a photographic one. A theoretical concern becomes an observational reality. And a curious scientist's warning becomes much more difficult to ignore. Craggs' capture sits at the center of this growing storm. The elongated shape in his image does not look accidental. It does not look like a tumble-broken shard. It looks like something built to withstand the interstellar medium, an environment that shreds fragile structures. The surrounding glow doesn't behave like a coma either. It is smooth, uniform, almost plasma-like, lacking the chaotic dust scatter that defines natural comet activity. Even the color is unusual, an electric cyan fading into deep blue. Comets do occasionally emit blue tones when certain gases fluoresce, but never in such a clean, symmetrical envelope. Meanwhile, the brightness variation footage adds another puzzle piece. Comets can brighten rapidly, yes, but not in perfect waves, not with such clean periodicity, and not in a way that aligns with rigid geometric structure. Natural cycles are messy, influenced by rotation, surface variability, and uneven outgassing. What Ray captured, then later shared and enhanced by Drew, looks far more organized. As more of these images accumulate online, a pattern forms. Not a conclusion, not an accusation, a pattern. First, the hints, a faint stretch of structure, a subtle glow. Then the shape, circular one night, elongating the next. Then the pulse, a light that intensifies with mechanical regularity. And finally, the reveal, the object in Paul Craggs' frame, clear enough to raise eyebrows in professional circles, precise enough to cause unease, and strange enough that many observers hesitate to call it a comet at all.
Still, responsible analysis demands restraint. Natural explanations exist. Some astronomers argue that the glow could be an optical artifact. Others say the pulsation might be interference or atmospheric turbulence. Some claim the symmetry is coincidence, a result of over-processing. And there remains the possibility that different materials interacting with sunlight in unusual ways could produce unexpected visual effects. These alternatives are important. They keep the conversation grounded. But they also struggle with the same obstacle: the consistency of independent observations. Different telescopes, different nights, different continents, and yet the same structure keeps emerging. The same smooth halo, the same elongated core, the same brightness pattern. At some point, coincidence becomes pattern, and pattern becomes anomaly. The question now is no longer, are these images real? They clearly are. The question is, what are they showing us? Because each new amateur capture seems to sharpen the mystery instead of dispelling it. Every night, someone somewhere uploads a slightly clearer frame, a slightly more defined silhouette, a slightly more convincing hint of structure. The object is coming into focus, and what it's revealing doesn't look natural. And if tomorrow's images sharpen again, if another amateur locks onto the object with even greater clarity, If the core becomes more defined and the symmetry becomes even more undeniable, then we may find ourselves confronting a possibility that scientists like Avi Loeb have long urged us not to dismiss too quickly, that some interstellar objects may be technological rather than geological. No conclusions, no definitive claims, just an unfolding record of anomalies that fits together a little too neatly. For now, 3i Atlas moves silently across the void, revealing itself in pieces, frame by frame, night after night. And it leaves us with the unsettling sense that the universe may be holding something in front of us, something hidden in plain sight, waiting for the right eyes to notice. If the next round of amateur images sharpen further, if the geometry becomes impossible to ignore, then 3i Atlas may not simply be too perfect to be natural. It may be something else entirely, and it may be trying to tell us something.